Hello everyone and welcome to the channel. So today we will just do a question on how to find the inverse of a matrix. We will be considering a 2 cross 2 matrix for today, and in the next lecture we will just do a question for the order 3 cross 3. So as far as the definition of inverse of a matrix is considered, if you have watched through the previous lecture, it was nothing but if I get a relation such a way that my AB is equal to BA is equal to identity, then we say that inverse of B is A, and on a similar basis, the inverse of A is equal to B. Kindly go through the lecture if you haven't seen it. Here, A and B are my different matrices. Now, this was the formal definition, but what if I'm given a matrix? How do I find my A inverse? That is the main question. Now, what we will here use is my elementary operations. This is something I have discussed in my previous lectures as well. I have made a playlist of videos consisting of every topic which I have discussed till now. Just go through it if you have any doubts. So, using my elementary operations, I will find my A inverse. As a note, just remember that I will be using row operations only. I will not do column operations because row operations are way easier to do. So, this lecture will only consist of my row operations to find the inverse of a matrix. We know that this relation is valid in terms of like I can write my any matrix A as a product of my identity in the matrix itself, because the identity matrix plays the role of one in my real number. So if I multiply my matrix with the identity matrix, it will in turn give me back my matrix A. We will just use this relation in such a way to find the inverse of my matrix. How? Consider this relation. If I post multiply A inverse, post means on the right hand side, if I will multiply here as well, what I will get AA inverse is equal to my identity. I'm just keeping this portion as it is. This is again my identity. So this is also a way that I can write my relation, right? So the main agenda is that we will start with this expression using the elementary operations. I'm writing it in the short form EO. We will just apply several row operation or addition or scalar multiplication in such a way that we will get this relation A A inverse is equal to identity. That is, my right hand side is in such a way that I will get identity. So anything that matrix which is multiplied with my A will give me my A inverse. I will just consider an example so that it is clear. Let us just recall that we find the inverse of square matrices. So as the case one, I will be considering a 2 cross 2 matrix. Also, I can write this relation that if I'm multiplying my matrix A with my identity, I will get the matrix A itself. I need to convert this this A using elementary operations into my identity matrix, so that what I'm multiplying with my matrix A, that I'm getting my identity is the inverse, right? So this is the main agenda. Now just substitute the value, and if I will write my A, I'm just writing the A itself. This is my identity, and here I will be substituting the value of the matrix. Just see whether this relation is clear to you. Then we will just now apply the elementary operations. Now just focus on the fact that the main idea is that I need to convert this portion into my identity matrix. What is my identity matrix? This is the form, right? How we will do it is, I'm just focusing on the right hand side. Then I will just explain it to you overall how we will do it. The main idea of how to convert the matrix into my identity matrix is that first we will focus on A11. Focus on A11. Okay. Now if we will focus on A11 and compare it with my matrix, one we have already have one, so there is nothing we need to do. Then we need to make the rows below them as 0. Why? Because if you will focus on this matrix, the value below it is 0. So I need to make this 2 as well 0. Okay. After I will make this my value 0, and like after I'm done with the rows beneath it, I will move to my next diagonal element, which is A22. Because in 2 cross 2 matrix we have only two diagonal elements, A11 and A22. So first we focus on A11. We will make everything below it 0. Then we will move to A22. Then, like I'm just making it as a triangle. So after making this value, now what is this? This has to be made as 1. Why? Because we are always comparing the matrix with my identity matrix. After this is made 1, make the rows above it as 0. Why? Because again we are comparing it with the matrix. This is the value 0 over here in my identity matrix. So this too has to be made as my 0 as well. So this is the main criteria how we will just do it using elementary operations. Now we will just apply the operation now. Now as a process to make my right hand side as identity, just focus because this is already 1, we need to do nothing. Now focus on the 2 because we need to make every value below the row as my 0. So just focus that on which row I'm making. This is my row 1 and this is my row 2. On which row I want to make such an operation is my row 2, right? And so we will just focus on row 2. This is Rn2. Just go through the elementary operations video if you're not clear with this step. I need to transform this row in such a way that I'm making changes in my row 2. I'm subtracting twice of my row 1. Right? Why? Because 2 minus twice of row 1. What is my row 1? Row 1 is 1. So this will give me the value 0. Okay, now just focus that this operation is only applied on the row 2 and I am applying it on this matrix. This will also apply on the matrix on my left hand side. If you can observe that I'm not making any changes in my row 1, so it is as it is. And as far as the row 2 is considered, this is the changes which we will see is that this was my row 2 minus twice of row 1, which is nothing but 0 minus of 2 cross 1, which is minus of 2. And 1 minus twice of 0 is nothing but my 1. And now here, this value is 0 because that is what we intended to make this value as 0. And now this value, how did we got is, this is my row 1 minus twice of my row 2. So this is nothing but minus 1 minus of twice of my 4. So I hope so that these changes are easy to understand. Now we will just write it. If we will focus, this is the real matrix which we will get as a result. Now again, we will compare this part to my identity matrix. Okay. Now, as I've said that we make this value as 1 and we have made the subsequent rows as 0, then we will just jump to the next diagonal element, which is my minus 5. Now, if you will compare this with my identity matrix, what we need to do is I need to change my row 2 in such a way. I want my row 2, that I'm dividing my row 2 by 5 and I'm multiplying it with the minus of 1. Why I'm doing this? Because I want to make my minus 5 as my 1, right? So what can I do is divide it by minus of 5, right? Then only I can get my 1. Again, we are just making changes in the row 2 and row 1 remains unaffected. If you will observe that my row 1 is not changed, in my row 2 I'm just dividing every element by my minus of 5. This is value 1. Now that we have got this value as 1, what is the final step to get to the identity matrix is that I need to make this part as my 0. How we will do it? I will use this 1 to make my value 0. I'm working on my row 1. I need to transform this row in such a way that I am subtracting twice of the value of my row 2. Why? Because I'm considering my row 1, I'm subtracting twice of my row 2. What is my row 2? This is my 1. So this will give me the value 0. Okay. So after applying the operation, this my right hand side will just become the identity. And as far as the left hand side is considered, I'm just applying operation on my row 1. So my row 2 remains unaffected. Okay. So my row 1, it will become R1 minus twice of my R2. What is my R2? R2 here was my 2 by 5. So this is what I've written. And the same over here, 0 minus twice of my 1 by 5. So this is the answer, final answer. So this is a matrix which I've got multiplied with my A, and this is my identity. Okay, now what this value will be such that I'm after multiplying it with A and that I'm getting identity is nothing but my inverse, right? So this portion is my A inverse.